In this video, we will see code implementation.
Now let's discuss the approach one that I discussed with you. Okay, so in the approach one, we have one rob function. Okay, that is passing function that is passing nums, right? And what I will do here, I will basically return this function. So, but inside I want some value, so I will define my DP. Okay, and here I will simply say I will create one function. So I will say where hrob house robbery is equal to function and nums of I. Basically, I want to create this function, right? And what will be my answer? My answer will be the method.max of two calls. Okay. So one function call hrob will be the nums of value with 0, and one function call will be same hrob function with nums as an input and 1. Whichever the maximum will be my answer, and I will return answer, right? And now what is how your house function will be like? So how I will say, if I is greater than equals to nums dot len, okay, what I will say, I will simply return 0 because you are getting out of bound, right? Return 0. If your answer is already stored in DP, don't do a function call not equals to -1. That means, right, don't do a function call. I will simply say not -1, I guess, undefined. Okay, don't do a function call, simply return the value. So I will return dp of I directly. Okay, then dp of I is equals to, basically you will take it, so nums of I plus, now the result will be determined the maximum between the two function calls. So method dot max of if house robbery nums with I plus 2, this will give me the maximum result, or the house robbery with the nums and I plus 3, right? Whichever the maximum will be my result, and I will return dp of I, right? So yeah, this will be one of the approach that I have discussed in the first. Okay, basically you will get the result by this one. We are using dp. Now what is the next approach? In the next approach, we are generating subsequences with non-adjacent values, right? So I will generate subsequences with non-adjacent value. Let me call the same function with approach 2. Okay, so I have a rob function, I have a dp, I have house robbery, right? What I will do, my answer will be, basically I will remove this answer and I will write hrob and nums dot length. Basically I'm finding from here dot length -1, right? This will be my answer. We will do the same thing, take and not take. So what I will do here, so in this function, let me condition, base condition will change, right? dp of I will be remain same, right? Like if there is something in dp, simply turn dp, right? This condition will be changed, right? So basically what we will do, let me answer it, we will return dp. So I will take one function that if you are taking that, so basically nums of I plus, if you are taking it, you will call the function with a lower of I minus 2. So I minus 2, right? You will go, you will take a jump, right? If you're not taking it, then you can take an adjacent jump, right? So not take, then so by 0 plus 0 plus, basically 0 for our understanding, 0 plus h of, we will have nums I minus 1, right? That means take it. Now what we will do, we will find the max. So dp of I basically will be the max of dot max of take, not take. Okay. I will return dp of I. Now there will be some base condition because you are jumping from the last element. So if suppose I is less than 0, so what you will do, you will return 0. That means that's an option answer. If you are coming to the last row, that means first element basically. So you will return that element. So terms of 0. And yeah, this will be our approach too, right? So basically what we have done, we have created one DP, and we are calling from the last, right? Now we are calling from the last. What we are considering, we will taking or not taking, right? And basically our subsequence generation without an adjacent. So I am calling I minus 2, not I minus 1, right? I minus 2 if I am taking it. If I'm not taking it, that means I can take the edge. I will call I minus 1. And whichever give me the maximum result, I will simply return to the answer, right? That is one solution, our approach 2. Now let's see the approach 3, the tabulation approach. So in tabulation approach, let me write approach 3. Approach 3, what we will do, we will simply, I will declare a function where rob is equal to function nums. Here in this function, I will define a dp, and I will say dp of 0 equals to nums of 0. Basically, my first element I am assigning to the dp as we did there, right? Now what I will do, I will start a for loop I equals to 1 to I less than nums dot length and I plus plus, right? And I will take a call, right? So I will take it. So how I will take it, basically I will say nums of I, right? Plus I need to do take it plus dp of I minus 2, right? Remember, but if I'm doing I minus 2, right? So it will give me I minus 1. So what I will do, instead of writing here, I will say if I is greater than 1, then update the take plus equals to dp of I minus 2, right? Whichever is maximum, right? That will be our take. And what will be our not take? So not take will be 0 plus dp of I minus 1, right? Adjacent, right? Whichever is maximum. Now my dp of I will be method dot max of take and not take, right? So this will be the my dp of I. In the last, I will return the dp nums dot length minus 1, right? So this will be my final answer of approach 3, right? Remember, we are doing the same exact thing like our recursion function. Basically what I have stored the things that I was storing in dp, I am now storing like here in dp. I am collecting the values from dp only, right? Now approach 4, where instead of taking these variables, right, dp creating an space, we can use simply variables. So what will be my approach 4 here is simply space optimization. So approach 4, right? Now what I will do, same thing, dp of 0. So I will say instead of dp of 0, I can simply take a last one. So this is my last one. And then I will take last 2 equals to 0. And what I will do, instead of dp I minus 2, I will say last 2, right? Why? Because see, it will be 0 when I will be 1. You will say it will run for I is greater than 1. So you can use 0 here. Here, this will be last, right? So it will be last 1. And the here, what will be my final answer? It will be last 1, and I will return last. But here, what we will do, we will change last 2 to last 1. So basically what I have done, like here, basically here I was checking dp I minus 2, right? The first element. Okay. And we are checking here dp of I minus 1. Basically we are checking the maximum of taking it from, and if you are not taking it, right? So you are dp I minus 2, the second last, and this is your first just addition. Here we are doing the same. Last 2 means second last, right? That is not been yet discovered. So last 2 is 0. Last one is adjacent last, that is nums of 0, right? So what I will do, my now what will happen, right? Once I1 will be done, right? My last one will be updated, right? So last one will be updated, but before updating, my last 2 will become last one, and last one will be the new last one, right? So it will update like this, and you get last one. Now all these 4 approaches, we will do the dry run of it. Okay. I will not do the dry run of approach 1 because approach 1 and approach 2 both are on recursion based. So we will do the approach 2 dry run, and from approach 2, approach 3, approach 4, we will check out all these dry runs with some examples. Okay. So in the next video, I will show you a quick dry run of all